Well, good afternoon, everybody. My name is Mark Orr. I'm the Executive Director of UK and Ireland Spill Association, and I am delighted to introduce you to part two of our webinar series called Red Tape versus Response Time. This is one of our conversational webinars, which seem to be our theme at the moment, and we're enjoying doing them.
Yes.
And today I'm joined by Dr. John Burton from Oracle Environmental, Adrian Brennock from ASP Environmental, and the lovely Amy Prose from Soccertech, who have kindly hosted us today, and they've just provided us with a lovely lunch.
Yes.
So
Yes. Welcome, everyone.
thank you very much. Thank you very much indeed.
Cool.
So this is the second part. First part, we had 3 spills and we discussed those. They were really cool. And you'll be able to see those if you go onto our website, www.ukeirespill.org. You can go and see it there. I would see that one before you see this one, though it's not essential and it's not compulsory, but it does increase our hits.
Yeah, absolutely.
So without further ado, I'm going to hand over to Dr. John Burton, who's going to whiz us into the second part.
Thank you very much, Mark. Much appreciated. And thank you, Amy, for hosting us.
Yeah,
And for
welcome.
Adrian for sorting. You too. And thank you to Adrian for sorting out the technical aspects as well. Much appreciated. So yeah, as Mark says, this is the second webinar in this series. And the first webinar was really setting the scene in terms of the sort of 3 spill incidents that we wanted to use as examples to highlight the issues around implementing remediation works and remediation systems on spill sites. So these are the kind of issues that we wanted to try and highlight within the presentation. So yeah, it's really around the kind of cost, inconsistencies, timescales, and the associated kind of issues around those aspects and how clients react to those aspects when dealing with these incidents as well. So I'm going to try and highlight through these sort of 3 examples how we've navigated our way through the sort of systems and managed to get treatment instigated out on site as well. So it's not all doom and gloom, I would say, and there is some hope for the future, which we'll sort of touch on at the end. And in fact, some of the examples that I've used are really good. You know, there's been some good experiences in dealing with the regulators, and actually, yeah, we couldn't ask for much better in some of those examples. So
in many respects, we're all on the same team. We're all trying to protect the environment.
Yeah.
100%.
absolutely.
And
The golden rule,
golden rule,
don't make it worse.
don't make
Very
it
good.
worse.
It's a good statement to live by. Don't make it worse.
Yeah.
So I think, you know, at the moment, it requires quite a bit of pragmatism on the part of EA officers to deal with these kind of issues and ones that we'll be talking about. And I think one of the things that we'll be talking about, you know, trying to instigate is some change to the kind of regulatory regime so that it is proportionate and appropriate, and it doesn't therefore need to have that pragmatism. It just is the right way of doing things. So this webinar, I guess in particular, kind of gets into the nitty-gritty of how we've sort of navigated the permitting and consents in relation to getting our treatment systems installed on these sites. And it's really about kind of the way that we've engaged with the regulators and the sort of, I guess, highlights and pitfalls of that process. So that's what we're trying to highlight in this webinar today. So yeah, let's carry on. So this was the summary from the previous presentation. And essentially, this was the 3 spill incidents that we were looking at. And yeah, not all spills are of 1,500 litres, I should stress. Some are larger, some are smaller. But these particular 3 examples were all 1,500 litres of fuel. But the examples we've given are of different fuel types. We've got a diesel, engine oil and kerosene. And there were some common themes across these 3 incidents. And the key thing, I guess, across the 3 incidents is that there was lots of free phase, so the pure fuel sitting on relatively shallow groundwater at all of these 3 sites. So we want to try and start to be able to recover that fuel quickly to remediate the sites as quickly as possible and prevent wider migration, reduce risks and all that sort of stuff as well. So that's exactly what we've tried to achieve here. So we've tried to get systems installed as quickly as we can to get control and prevent wider migration of the contaminant as well. So in terms of the challenges faced, then some of the other companies in the industry will no doubt have come across these issues, and I'm just trying to highlight some of those here. So we've essentially been told that the Environment Agency in England are no longer accepting sort of local enforcement positions, for example. So that basically the stance that the local EA office will take, and they will say that, well, you you can do this and we won't prosecute you, is essentially what they're saying. So that is now removed, so they can't adopt these local enforcement positions. And the reality that we're seeing at the moment is that actually we're not sure that is being strictly applied across the country, and it still seems that some areas are accepting them and others aren't. One of the other things that they also looking at is they don't accept what's called the de minimis, or which essentially means the absolute minimum, the sort of low, which is a low risk kind of stance with regards to discharges from treatment systems. So it used to be the case that if you could demonstrate that your discharge was of such a low concentration that it didn't pose a risk to the environment, then you could carry on with that discharge. That, in theory, again, is no longer accepted. One of the other restrictions, if, for example, you have got a foul sewer available on site, if you're working in a kind of more urban, commercial sort of environment, then you're likely to go to foul sewer in terms of your discharge, and every sewer has got its own constraints in terms of how much flow can actually be discharged to that sewer. And that has proven really challenging for us on some sites. So, for example, we've got, I guess, what we describe as semi-rural sites where you've probably got a small treatment plant somewhere in the village, for example, and they're really restricted in terms of what they can take and discharge. So we've had one in the last couple of years where we were only allowed to discharge 1 meter cubed per day. So, you know, it's such a low volume to deal with, but there's literally no choice. If you can't go to ground because there's a sewer available, that's what you've got to do. And then the time taken to obtain permits and consents as well, that can be a real challenge, and I'll sort of detail those with regards to the different incidents as well. And then also, of course, it's important to look at the costs and the potential sort of increasing cost involved in installing pump and treat systems. And, you know, that's of key concern to clients appointing us to carry out these works. It's like, is the cost reasonable?
And I guess the impact that any delays in response time and response activities, or your ability to adapt and be agile in terms of changing approach, because it evolves, doesn't it?
Absolutely. Yeah. It does. And, you know, and we need to consider a wide range of factors and cost, time, sustainability as well. These are sort of key things that are being sort of considered when we're looking at the best approach to dealing with a spill incident. So we try and factor all of those into the decision making, and I think the regulator should too. And I've just highlighted a little bit here from the regulators code, and this basically says that regulators, in making their assessment of risks, should recognise the compliance record of those that they regulate, and that includes using earned recognition approaches, and should consider all available and relevant data on compliance, including evidence of relevant external verification. And that
is surely, and I have to say, the ISAS, International Spill Accreditation Scheme, has been designed in partnership with the Environment Agency in the UK and all other regulators, including the MC on the marine side, but they all sit on the accreditation steering group. And we have an annual meeting with them where they get the opportunity to review the system. And in fact, recently we've taken the accreditation scheme and written a standard, which is principally authored by yourself, but has gone through all the regulators, such that we have a robust, a very resilient and continually reviewed accreditation system. And we would like to think, and in fact, the regulators have often said it, that they recognise that the scheme, which is the only scheme in existence in the UK, should exactly comply with what they have said there.
I think there's a real role to play for ISAS in particular here. You know, for example, if ISAS accredited contractors can essentially have a stamp of approval, if you like, to say that this system is effective, it does what it's designed to do. And in that scenario, then the regulators potentially should take a kind of lighter touch approach to the regulation, because you know that it's a system that's gone through a series of reviews and approvals and is appropriate to be implemented on a site. And that's, if you've got that sort of stamp of approval, then it should be deemed as being a lower risk. And I think, again, sort of coming back to Adrian's point about not making things worse, it's, you know, these scenarios that I'm presenting on here, we're trying to remove pure fuel from the ground and discharge clean water. And, you know, if it's going back to ground, then we cannot be making it worse because we're literally stripping the fuel from the groundwater
Yeah.
and returning that water back as well.
Yeah, and I guess, I guess it's the Environment Agency or the regulators, they need to be reassured, don't they? I guess that if you're putting water back in, that you've got control on that groundwater regime, and you're not essentially putting it in a place which is going to push contamination
absolutely
away. So, but that's where, around that competency and accreditation perhaps comes into play.
And surely the discharges also, you analyze those.
Absolutely. Yeah.
And you
That's where Amy comes in. Yeah.
Part of this, don't you,
Yeah,
Amy?
we do, yeah.
And it's
And actually, in these cases, in the design and therefore the verification, they're on a pretty fast turnaround, aren't they?
absolutely, yeah. It's a key part of the kind of process, and
It helps with your response times and everything as well.
it's the data that we use to prove the effectiveness of the treatment system at the end of the day, and that the discharge is suitable. So it's a fundamental part of what we do, and kind of quick turnaround of samples is key to that as well.
And good, reliable data that's accredited.
Absolutely. Yeah. And I'd expect the regulators to be asking for that sort of data as well, and a sufficient amount of safety features built into any kind of system that you implement on a site as well. So,
but I guess are we, and just maybe we're getting a little bit off topic, but in terms of, are we thinking that the ISIS accreditation, or there could be like a response period, because that kind of period where you're in the response phase, and what you do in that phase can have a real positive benefit in the longer term. And you need to do it quickly and everything else.
Well, you have that golden time in the spill, don't you?
Yeah.
Where you've got to control it.
Yeah.
You've got to get it under
And
control.
then,
Time lost is
exactly. And I guess my point being that maybe the traditional permitting approach is then there to deal with, if you're going to be there for years, then obviously you can then move to a more traditional permitting. So you need that flexible, agile, responsive regulatory approach in the initial phases, where you don't have necessarily the detail of how many cubic meters an hour you're going to need. You don't have
because
anything
actually
like
at the start you don't know.
No. So that's the challenge. You don't often have the data to fill in the paperwork to get it anywhere. But
it's a really good point, and I think fundamentally the issue that we've probably got is that the current approach to regulation has been built around kind of shoehorning what we do as spill responders and remediation contractors. It's shoehorning that work into waste legislation and into kind of water legislation. So it's no doubt a really difficult thing to do to try and do that, but at the moment the way that it is set up just doesn't really work.
So it's kind of like but I guess it's where code of practices and kind of accreditation can come into play to kind of say, well, if you're following the code of practice and you're accredited, then as long as you do, if it carries on beyond a period of time, and once you've got the information, then you have to move to more regulatory.
And I think one of the things which we have worked with the Environment Agency on is land contamination risk management, where they do recognise that it is important to have accredited contractors involved in this, and they do recognise the scheme as being part of that. What we would hope is that we have that trusted contractor status, such that we should be delegated immediate response decision making to protect the environment.
I think I'd always expect an element of review and kind of scrutiny, but I think where it currently sits at the moment, it's almost too onerous, and the process doesn't need to be, because in fact the kind of processes that we're talking about in the systems that we'll be describing, they're relatively straightforward. And one of the issues is the cost that I'll touch on, and the reality at the moment is that the cost of dealing with a fairly straightforward spill incident is the same as dealing with a really complicated gasworks site, for example. It's like, how can that be the case? It's like, surely the review time should not be as significant as when you're looking at a complicated case like that.
No, very true.
I've got a quick question going back to what Mark Orr said about the golden time and response time. What happens when you miss that golden time, as he calls it.
I think it depends on each site. Each site's going to be different, but I mean, one scenario would be, for example, if you've got lots of kerosene or diesel or whatever around a site, it's at shallow depths, and then you've suddenly got a lot of rainfall, and then it just gets washed off site onto another site. And you know, the case study 3 is an example where that could have happened, and it could have then migrated onto, you know, the triple SI, which is next door. So there's no specific set period. It's going to be dictated by each site.
That's why spill response is so different to some of the contaminated land sites, because you do have to respond within that golden time.
Exactly. So it's done that it's emergency works rather than planned work. Exactly. Is what contaminated land remediation is. Planned work generally.
And in a spill, a lot of it you learn the extent of it as you work through your dynamic risk assessments from an environmental standpoint.
Absolutely. You're learning new things when you're opening up new holes and all that sort of stuff as well. So it's response and investigation, which we did touch on in the first one.
The environmental conditions will change over time. So you might have a shallow groundwater at the time of the loss, but actually, you know, in that particular environment, it might be that the water level drops 2 or 3 meters. So then you get a smearing of all that contamination across that ground. So what was recoverable is now basically in the soil and in the pores, and that then, as the water table over the next couple of years comes up and down, it just washes it out, and bit by bit.
That makes it more difficult for you guys as well.
Well, 100%. So so time is critical.
Absolutely, time is critical, and that's part of the reason why we wanted to have this conversation.
Absolutely. Absolutely.
So well, I guess I'll sort of illustrate, you know, that discussion a bit more as we talk through the examples. So going back to spill incident 1 then. So this was, if you've seen the first webinar, this was a water supply site where there'd been a spill of diesel from a standby generator. We'd carried out some source excavation works and put in some interception trenches and recovery sumps. And we wanted to implement a recovery of that diesel that we'd found on the shallow groundwater, and recover it from the sumps, but also from some of the kind of manhole chambers that the diesel had made its way to as well. So in terms of response times, so we first attended back on the 10th of January 24, commencing those emergency excavation and interception trench excavation works. And by the 15th of January 24, about 630 litres of diesel had been recovered directly from trial pits, and then a further 100 litres from sort of use of absorbents and what have you as well around the site. So it left about 770 litres of diesel unaccounted for. So basically, we were able to work with the EA and get a system installed on site. So this is a groundwater treatment system, and that comprised a combination of float switch operated pumps that were put down into the recovery sumps, skimming pumps, and they all discharge to a trailer mounted oil water separator that you can see in the top photo there. So you've got a large oil water separator, and then we've got 4 granular activated carbon filters, 2 of which are on the trailer mounted system, but we wanted to add an extra kind of polishing step. So you've got basically double lead lag system in terms of your treatment of the dissolved phase hydrocarbons there. So that basically was installed on the 19th, and with the discharge going to ground. So
are those fairly common when you say treatment systems? So generally there's pumps which pick up and push the water through an oil water separator, then they go through activated carbon filters, and you design a system based on the throughput, the size of filters, and and the level of contamination you're expecting to absorb. Is that right?
Yes, to all of those. Yeah, all absolutely. Yeah. That's exactly
it. Why you're a doctor.
So, I mean, as you say, kind of every site is different and presents its own challenges. Because we got kind of shallow groundwater on all these sites, you know, we're using float switch operated pumps. If it was deeper groundwater, we might use some different pumps. We tend to use kind of air operated. So you'd have a compressor module using air operated pumps on those, which are sort of top loading, so that you're only taking the fuel, that sort of thing. But the treatment element of it is nearly always an oil water separator, which takes out your pure fuel, which you can see, ably held by a colleague of mine
Yeah.
in the container there. So we were literally pulling out pure red diesel
Yeah.
and lots of it
Yeah.
in the early stages
Yeah.
of that system there. So the ore water separator, and then you're polishing off your dissolved phase hydrocarbons through the carbon filters as well.
Because I guess the key one being is if you allow the free fuel to just go straight into the carbon, it would kill it.
Oh, no,
straight
no,
away.
completely.
So,
Absolutely.
yeah.
Yeah. So you'd be having to change it
Yeah.
on a
Yeah.
regular basis.
Yeah.
so the impact on the
Well,
environment.
actually, and the cost.
And the
of project
cost,
too.
yeah.
Yeah. That is great. Thanks for explaining that.
So, in terms of how we went about kind of getting that system installed, then, so the EA were notified of the system installation, and that was under what's called RPS 215. So that's Remediation Position Statement 215, which essentially allows the discharge of small volumes of contaminated groundwater to ground under specific conditions, which I'll talk about in a second. So one of the key limits on that RPS 215 is a volume related limit. So if you treat more than 1,000 meters cubed, or if your system is going to be operating for more than 6 months, then you should deploy a standard rules permit for land remediation.
And that's it's a threshold that's been around for a long time.
It has, yeah, absolutely. So that's the approach within England, that if you're going to go over that kind of volume, then you need to deploy a mobile plant permit, as it's called. So that's what we did when we knew that was going to happen.
This 1,000 meter cube, is that over the cycle of the whole project?
Yeah.
So it's not within a month, it's not within a week, it's
the whole volume, and it also includes it should include the soils and the waters. So if you're treating both, then it needs to include that as well.
So that's a really small in the 3 instances that we spoke about in webinar 1, or each 1,500 litres spills coincidentally, you're going to expect to cover many times that many.
One of them, in fact, so the second one I'll talk about in a minute, that one we haven't deployed our permit yet. That's not to say that we won't. It's still ongoing. But the flows that we're dealing with on that one aren't anywhere near as significant as the flows that we're dealing with on example 1 and example 3.
So basically, one of the points then is that the limit, by being an absolute for the whole project, is just too small.
Well,
or in many cases it's too small.
I think it's fine as long as we're clear on kind of the need for it, and then the associated cost of deploying the permit. I don't have any objection in terms of having that permit, and because it does essentially, again, it demonstrates competence, because you need to have WAMI to have approved competent staff to actually have that permit and to then be able to deploy it onto different sites. So I don't have any objection with the need to do that per se, but it's kind of the associated cost of deploying it that I think is kind of the issue at the moment. And one of the key things sort of shown, I guess, in these photos here is the kind of data that you should be collecting when you're installing these systems. So I mean, it's fairly basic, because you'll recognize some of these bits and bobs, but the top photo is a flow meter. So you're literally, every time you go into site, you're taking a record of your flow that's gone through that system, so that you can actually confirm whether or not you're anywhere near that 1,000 meters cubed, or that you're ever going to get likely sort of close to it. So with this system, we discharged to ground, and that was within the boundary of the site. And we did have some to and fro with the Environment Agency, and ultimately we were able to convince them that it was of low risk, and that we were treating it to a sufficient level that we were able to discharge to ground. The use of the flow meter, that allows you to kind of assess kind of flow rates of the discharge. And we were able to establish quite quickly that we were going to be exceeding that 1,000 meters cubed limit on RPS 215.
Right.
So we deployed our mobile plant permit. So the permit application was made on the 26th of Feb, and the permit was issued on the 19th of March, 3 weeks later. So, I mean, and that is a really good.
That's really good.
That is a really good turnaround time, and we gave some positive feedback to the permitting officers on that one, because it was brilliant. And again, I mean, we were able to continue the operation of our system under RPS 215 whilst that permit deployment was being reviewed. So that's the key kind of pragmatism that you want to see. It's like, well, actually, we want to carry on cleaning up the environment here whilst we're sort of having that permit deployment reviewed. So it's all in all quite a good experience in that regard. So what did we see in terms of the sort of recovery? So this is just a graph of kind of cumulative flow through the system, and we had basically from Jan 24 to Jan 25, we treated 2,658 meters cubed of diesel and diesel contaminated water, to the point that we managed to achieve no free phase diesel anywhere, and very low concentrations of dissolved phase hydrocarbons as well. We're currently sort of assessing the need for further treatment, and there's ongoing monitoring just to ensure that we've achieved the kind of goal on this one.
This is on taking samples,
Yeah,
getting them analysed,
absolutely.
and completing your data sets.
Yeah, exactly. So it's the data that we would collect for verification purposes, if you like. So we're collecting samples from the recovery sumps that we've installed, and some of the manhole chambers as well, just to confirm that we've achieved a sufficient level of cleanup. So that's the graph. As you can see, the kind of early stages of that graph are key, because they're some very high flows through that system. But overall, we had a sort of abstraction rate or treatment rate of 7.5 cube a day going through the system. And that's what we saw. Excellent. So we've gone from January 24 with free phase diesel in the ground and lots of it, all the way through to January 25 with crystal clear water.
That's a good picture.
So, and the other thing I wanted to stress, that the alternative to deal with that kind of volume would have been 100 articulated vacuum tanker movements, for example. It's a fairly simple comparison, but as I think we mentioned maybe in the first webinar, it's not just the volume that you want to remove, it's actually having control on that site. So with the system that we had installed, it was 24/7 control of the groundwater and removal of the groundwater and the diesel as well. So, and we've removed all of the diesel from the groundwater, and by discharging it back to ground, there's no net loss of water. So from a sustainability point of view, in terms of your water cycle, that you're net zero, because you're returning that water to ground.
And are these remediation systems remotely monitored?
They can be.
I mean, one of the things you Adrian has been stressing is that some of your work is remote.
Yes, I mean, so it can be quite, it can be quite far, and I'm sure the telemetry is kind of, again, it's a bit like the technology, and I guess why we're saying they're really, it should be relatively easy to assess and to kind of move forward with, because it's all kind of fairly readily available now.
We don't typically have the extent of telemetry on these kind of systems that we would say for a contaminated land or a big kind of remediation job like that, principally because the cost involved. But we do have telemetry in terms of text messaging that will say when there's a problem with the system. There's high level alarms that are set within the system that will trigger and will turn the system off, and it will tell you that the system's off. But you can go to the nth degree, but you've got to try and convince your client to pay for it at the end of the day.
No, I understand, but it is been that it enables it to operate 24/7.
Yeah, absolutely.
With safety, with an umbrella,
with the appropriate safety features. Absolutely. Absolutely.
And I think we did a failure mode effects analysis on a system for a client a long time ago now. But one of the reasons we did that was they had an issue in the States, interesting enough, using telemetry and control, where there was the system tripped out, and nobody knew why, and they had so they restarted it remotely, and actually there was a leak, and so it literally then continued to pump out, and suddenly it was in the news media. Local residents filming this, just pumping contaminated water out onto the ground, essentially. So I think it's the challenge with technology is, unless you think, right, if I put this into place, what could happen? So one of the things we had on that system that we designed was that essentially you couldn't, it was literally a fail safe, so that if it tripped out, you had to go to site to restart it. And I think it's just one of those lessons learned that was learned by the client on another project, but they were keen to make sure that all of their contractors learned it as they went forward.
So we have actually must be a danger in when you have a system that actually, you know, particularly in a rural location, that actually it could be tampered with unwittingly or deliberately.
Potentially.
Stolen. Well, you know, it's on wheels.
Hopefully not, but I mean,
but that's
I mean, there's obviously measures that you can try and take, and I mean, some of the systems that we've developed, we've got sort of mobile treatment units, which are essentially similar kind of trailerized systems, but they've actually got a roof, if you like. It's like a horse box type trailer, and they've got built-in kind of CCTV cameras in them as well. So you know, you can add sort of levels of security as needed.
Good.
So,
Thank you.
So in terms of the kind of permitting approach then, so just to recap for incident one, so RPS 215 was used, but there was some to and fro with the agency, as I said, and initially they had suggested, well, can we not go to the foul sewer? But that was on the opposite side of this A road. There was literally no way that we could get to that sewer safely. So the best option was to convince them that it was appropriate to treat and go to ground on this one. So RPS 215 was applied. That does need 5 days notice in terms of providing, you know, a letter detailing what you're planning to do on the site. You send that to your local groundwater and contaminated land team, and they then review what's being done. So that's the kind of minimum timescale, if you like, that you'd expect to be able to get a system onto site is 5 days, really. So the EA accepted the installation of the system, you know, under RPS 215 with the proviso that there were adequate safety features and the appropriate monitoring that we talked about earlier as well, in terms of sort of collection of samples to prove that it's doing what it says it's meant to do. So high level alarms, regular monitoring of the discharge, but there was a requirement to deploy our mobile plant permit due to the length of time of treatment, but also the volume that was going to be treated as well. So this is the brief kind of summary then for incident one, and that's timescale from first attendance to installation, 9 days. Not too bad. There was some temporary kind of pumping and removal, you know, within that sort of initial period, and that was going to kind of IBCs and other kind of storage containers on site. But it doesn't give you that 24/7 control that we talked about. And then the timescale for permitting approval for the mobile plant permit, 3 weeks, which is great, really good timescale. They, you know, I think it's in theory they say up to 8 weeks is typically allowed, but sometimes it can be longer. So 3 weeks is great. And the permitting cost, the cost to deploy the permit is £3,000. And as I said earlier, that's the same for, you know, a big kind of gasworks site compared to a small spill site.
Quite a high cost.
It is. It is. I think the issue is that it should be proportionate to the incident, and when you've got one contaminant such as diesel, kerosene, engine oil, and you've got an established treatment process like an oil water separator and carbon filters, it should be relatively straightforward to look at the risks, and you do a surface water features survey, you do a groundwater risk assessment, just to, in terms of qualitative, I mean, just to assess the potential risks involved within a discharge. But those are fairly simple things to carry out, so it shouldn't take that long to review, that sort of process.
No, and the key one is, you know, carbon is the industry kind of standard catch-up
absolutely
for this type of contamination. So as you say, it's so well established, it's been used probably for over 100 years.
Absolutely.
So you know, it's
I mean, even on most water company sites will have carbon filters to strip out any potential contaminants that come through.
Carbon.
Yes.
Yeah.
So no, it's as I say, it's so well established that's you say the risk is really minimal
Yeah.
if you've got enough carbon and you've got that lead lag in
Yeah,
play.
and it comes back to what we were talking about earlier, which was the kind of ISAS approval of a system to achieve the desired kind of goal, which is to strip out everything from the water and then discharge clean water to ground. And hopefully, if you've got all of those things in place, then it should be a really swift process.
One of our recent members, Desitec, have been educating me on activated carbon because they shift a huge amount of it.
Yeah, we use them
into
quite a lot.
water and into some of our members.
Yeah.
Good stuff. Okay, so the second incident was engine oil, so slightly different fuel type, but again there was a need to remove the engine oil from the ground. So I don't know if you remember from the first webinar, but we had a kind of an open excavation on this particular commercial site. With Trinity Environmental doing the excavation and installation of these recovery sumps. So to allow us then to put pumps in again to actually pull that engine oil out of the ground. So we were first asked to provide a price for a treatment system. I think it was on the 4th of October 24. And the system again was going to be installed initially under RPS 215. The difference on this particular site was that there was foul sewer available. So we had to be looking at getting that discharged to foul sewer, and the mechanism currently for doing that is to apply for a trade effluent consent, because the effluent from a treatment system such as the ones that we're talking about is regarded as a trade effluent. So you've got to go and apply for a consent to discharge.
How do you find those at the minute? Because we find them variable.
Yeah, absolutely. Really variable, and it's a very odd system at the moment, isn't it? Because you basically have to apply to the water retailer. It's not even the water company itself, it's a very odd system. Yeah, there's a set number of kind of water retailers that basically manage all of these consents.
No. So yeah, it used to be the case. You went straight to the water company in the area that you were working, and you could talk to them directly about what you wanted to do and the urgency and everything else. But now now you fill in a form that goes to the retailer, who then contacts.
Explain who the retailer might be.
I'm trying to remember some of the names now, but
it's not the water company. I find that surprising.
No,
it's something like Water for Business, for example. And there's a good number of other ones as well. But they manage that process for the water companies, it seems.
Okay.
So as a business, you have an account with this retailer. So irrespective of wherever in the country you might be in England anyway, that you might be looking to discharge to sewer, you would go the same route every time.
Okay.
Yeah, and it does present a real challenge.
Do they understand what you're doing?
Probably not most of the time, because it's quite unique.
They're just processing paper.
Essentially, and there is obviously a technical element to it as well, because they will liaise with the water company to agree the kind of limits that are going to be placed on the discharge. So there is a technical component to it as well.
I think it's always that. I think where our challenge is, by not having the direct conversation yourselves, sometimes things get lost in translation.
Yeah,
and it results in time delay as well, doesn't it?
Delay.
Yeah, so I think with the last one,
more friction in the system.
And that was a key thing with this example. Really, is the timescale involved in this approval for the consent to discharge. I think it's just far too long. So essentially, 12 weeks after we made the application, we had it through. So I've got the client jumping up and down saying, "Come on, we need to get on with this." It's like, well, I literally can't, because I haven't got a consent to discharge.
That's very disappointing when you think about how fast you guys move, and then the turnaround times and so on, and then you have to wait 12 weeks.
Yeah, I think
So what happened to the site in the meantime?
It just sits there. So but I think because it was a lower risk from an environmental point of view, the majority of the sites covered with hard standing. There's not particularly sort of sensitive groundwater or surface waters nearby as such. Although there was a drainage channel on the site boundary, I think it wasn't such a big concern compared to the other two examples that I've been talking about. So if it had been, then that would be a very different scenario, I think, and I think other people would have been jumping up and down to implement something else.
Yeah.
So but after the 12 weeks had gone, we installed a a 4 meter cube an hour treatment system, as you can see here. So again, we've got float switch operated pumps within the recovery sumps, and they're discharging to an oil water separator, and then through the lead and lag carbon filters, and discharging ultimately to foul sewer. So again, that system initially operated under RPS 215 and still is currently, and we haven't got the kind of high flows that we had on that first example I mentioned there. So we have got limits set, as I mentioned, on in the consent to discharge to sewer. So you've got limits in terms of flows, quantities that you can discharge, and then obviously certain components within that discharge as well. So you've got to make sure that you're proving that it's below these concentrations. And lo and behold, that's what we're pulling out is black oil.
Yeah.
Wow.
So and it does seem to keep coming. So whether that estimate of 1,500 litres was right or not, time will tell. I think on this one.
Yeah.
But yeah, so
That looks highly contaminated.
Yeah.
there's quite a lot of engine oil. So we're getting the kind of pure engine oil out of the ground, as you can see here again. So in terms of timescales from kind of first contact to system install, nearly 4 months. Nearly 4 months on that one.
Yeah.
Wow.
As we discussed in the first webinar, the properties of the engine oil meant that it was unlikely to migrate too quickly.
That's exactly that as well. Yeah.
But had that been kerosene, then it could have gone
Potentially, but again, it's the kind of the fact that it's covered in hard standing. You haven't got kind of rainfall sort of pushing it around. So the risks were lower. So the pressure wasn't quite as great in terms of timescales there, but it's still too long in my opinion.
It's really frustrating as well.
Yeah. On the plus side though is the cost.
Yeah.
So the plus side here is it £300 to apply for the trade effluent consent, and then there is a fee that's then levied in terms of how much you discharge. So but we've estimated that's probably going to end up being sort of around £450-500. So you know, it's a much lower cost than deploying the permit currently as well. So swings and roundabouts.
Yeah. No, S's and R's.
okay. Well, thank Lord your glasses are full then.
Absolutely, yeah, absolutely.
Yeah.
So the last case study then was this was, if you remember, a 1,500 litre kerosene spill on a domestic property, and lots of kerosene in shallow groundwater migrating around services. It had impacted the sewage treatment plant on site as well. It got into ponds, it got into streams, and there was a triple SI site next door as well. So so we first attended on the 24th of October last year. And started the emergency excavation works and sump installation just a couple of days later. And then on the 5th of November, we were able to install a treatment system, again, with your sort of oil water separators and granular activated carbon filters with a discharge to ground because there was no foul sewer available. That was done through RPS 215 again initially. But similar sort of scenario to the first example, in that we quite quickly saw that we were going to be getting up to the 1,000 meter cube limit, and so we deployed our permit as well. So not such a good experience in terms of approval of that permit. So that was submitted on the 11th of November, and the permit was issued on the 8th of Jan. So we're looking at kind of 12 weeks for the approval on that one. But I mean, on the flip side, we were allowed to carry on treating. So that's the key thing, that we were allowed to carry on operating our treatment system. So we had control, we had containment in place. If they'd have said, you can't do anything until you've got your permit issued, then it would be a different issue.
And I think that's, I have had that scenario where you literally go, no, you need to not do anything until you've got the permit.
Yeah.
Or else we might prosecute you. And you go, so you basically go, well, is it going to be in the public interest for the Environment Agency to take a prosecution in that regard? But equally, as a business, you have to take that decision. Are you going to, do something that's in the best environmental benefit, and which will ultimately have that positive impact, and then but give the risk, your reputational risk of being prosecuted, but equally business risk of having to stand up in front of a judge and go, I did it for all the right reasons and it had a positive impact, and eventually I did get my permit, so I would have been able to do it, but just decide, so it's really tricky scenario, I think.
So you feel John's pain?
Oh yeah, no, 100%. And I say, but it's this uncertainty. It's like it's the uncertainty in the timing. As you say, you've obviously got the relationship and you've made it work through the RPS 2 and 5 and then to keep things going. But I think that's not always the case. It's not consistent across the country.
Yeah, and I think that's kind of what we're calling for, really, isn't it? Is putting something in place that enables companies like ourselves to have a consistent approach and to know exactly where we are and to not be at risk of prosecution at the end of the day for trying to clean up the environment, which is what we're trying to do.
Yeah.
It just seems a crazy situation to be told, no, you can't get that kerosene or diesel or engine oil out of the ground until you've got this in place, and you have to use vacuum tankers or leave it. It just seems a crazy situation.
Because it's not always a given that you'll have the permission to discharge to ground.
Nope.
So, so particularly, as you say, there's all of these factors that come into play that we're having to deal with as part of a response, isn't it? Where everything is evolving. And, you suddenly find that, well, actually, there's some contamination over there that, in that area, I haven't got any power. The drains that, it's on the other side of the road. And suddenly you can't join things together, and you've got a whole new set of issues.
But particularly in spill incident 3, you've got a house, which is an old house with very shallow foundations. You've got occupants in the house who have had to leave the house because of the smell. So you're just extending the pain for them too.
Yeah.
And considerable. And while it's in the ground, there is still an SSSI just across the road.
Yeah. And because of the
taken 12 weeks to get the permit.
But
I know
they let us carry on.
You've allowed, you were allowed. But actually there's a lot of things.
There's a possibility that another EA officer in another region might have said, no, you can't carry on, you've got to stop. In which case, there could have been potential for more pollution to reach surface waters and reach the SSSI.
And then I guess I have used this argument sometimes. I guess, are you knowingly permitting at that point? So by allowing contamination to continue to enter groundwater from and migrate.
You as in me?
No. Well, you as in, if you did stop, basically, I was told on one job, I was told you need to stop until you get the permit. And I said, well, and I guess I played that argument out with them to say, well, it's in the best environmental option. Am I really going to get prosecuted for, is it in the public interest to take a prosecution? And actually, do I need to weigh up the fact that, am I knowingly permitting pollution to occur if I stop? So
I
think they hadn't had that argument before. And I think in the end, they went, well, you probably better keep going.
My response to that would be one example that I sort of put to a regulator, which was in essence, well, surely you're the knowing permitter because you're telling me not to remediate this site. Therefore, you're letting contamination migrate wider around site and potentially get off site. Therefore, you're the knowing permitter. That didn't go very well.
No, but it's that's the thing. I mean, the issue is that we all know that, behind closed doors or whatever it might be, we all want the same thing. We all want it to be cleaned up and the environmental impact minimized to the extent it can and then mitigated and the area restored. So we all want the same thing, but it's that sometimes there's these things that just cause tension.
Yeah, and I think that's exactly what we're calling for is some changes to be made to iron out those issues basically.
And the consistency.
And prevent the friction and just reduce friction and reduce the tension around it.
And like you said, a pragmatic approach would really help.
Yeah, well, in theory, if you've got a more appropriate and proportionate regulatory regime, then you don't necessarily need the pragmatism, because the pragmatism kind of is there to kind of weave around the current system. But actually, I think what we're asking for is just a proportionate and appropriate system to be put into place that we can all work to. So so the upshot on this one was that it was just under 2 weeks really from kind of instruction to first attendance at the site to installation of the system, and the this was the kind of flow that we were seeing through it. It's still currently operational at the moment on site. So 13 days from first attendance to installation under RPS 215. 12 weeks though for that approval for the permit. So, but thankfully we were able to carry on under RPS 215 anyway, and the £3,000 again for the deployment of the permit on this one. So that's a quick summary then. This table showing the kind of different kind of key information for each spill. So timescale from first attendance to site to system installation. So the key stinker there is really the one where we had to go to foul sewer, and that was principally down to the length of time it took to get that trade effluent consent. So I'm not sure that we're going to be able to change that greatly, in all honesty.
It's an interesting one, isn't it? Because it would be interesting to try and talk to the water companies, maybe the trade body, and just say, is there a way that we can look at that?
Well, we could do that through the Water Industry Association. And that could be trade association to trade association. And that's something we should do.
Just because quite often it might be that there is no net benefit or impact on the water authority or anything like that, but actually it might be that there could be a scenario where actually we're trying to do it quickly to protect.
Thing is, again, as we sort of touched on before, I can't see why it needs to take so long.
No.
Maybe AI is going to sort all this out. But because you're looking at some key factors. You've got a kind of known treatment system capacity in terms of the water company, so they know what their treatment system can accept. They know the size of the sewer that you're going to be discharging into, so they can quite quickly tell you what kind of volume they can take, and then you just add on to that your kind of concentrations that you're proposing to be discharging, which is non-detect.
Exactly.
So it really should just be plug some numbers in, and out comes your consent. I cannot understand how it can take so long. So
I think we should
do what you
have that
can.
Discussion. Water Industry Association. We're coming your way.
Good. No, be positive.
And actually, we'd love to show you this webinar.
So in terms of the timescales for approvals, then spill one, really spill one was a kind of that's the good example, if you like. I think really that's good. That's how we like it.
Good gold standard.
So and the only sort of downside for spill 3 really was that timescale for the permit, but it didn't really matter in that particular scenario because we were allowed to discharge anyway. So that was all good. So just sort of to round off, I guess the kind of changes that are needed. I'll add the sort of conversation with the Water Industry Association to this as well. But essentially, we need to get to a point where we're able to remove contamination swiftly, providing that there's appropriate safeguards and monitoring in place. I think we all have to accept that. ISAS might have a role to play.
I think in that the competent contractor bit.
So and it comes back to the second bullet point here: discharges to ground from demonstrably effective treatment systems should be accepted as posing a low risk and should be allowed to ground where appropriate. You're literally taking fuel out of the ground, like shown in this picture, and discharging clean water back to ground. So, as a low risk discharge, there should be no, or at least a low cost associated with the discharge to ground. Excuse me. And permitting costs, I accept that there may be a need for permitting in terms of deployment of permits, but the costs associated with deployment of those permits should be proportionate, and it should be based on the kind of time that's required to review any given kind of deployment of a permit as well. And kind of hot off the press on this topic, I did actually get an email from the EA yesterday in relation to our permit, which is a Standard Rules 27 permit, and they've now basically said that all permit applications will be online, and the review process will all be done online as well, with a view to kind of speeding up that process.
And is that, are they giving you a model? Are they within that giving you indications of the time it would take from application to approval?
I don't think they've committed to anything yet. I think the proof's going to be in the pudding, but I mean, they do say currently that it should be around 8 weeks maximum. Albeit we have seen some that go over that. I think it depends on kind of workload at the time, obviously. But I think, the intention of bringing it all online is to speed up that process. So that can only be a good thing as well. So, Yeah, and I'm aware that the EA are looking at this. They know it's an issue. Whether that will then extend to other regulators such as NRW and SEPA and NIEA as well, I don't know yet. But you do tend to see a trickle down effect once one regulator sort of implements something, that it gets sort of adopted elsewhere if it's deemed appropriate.
Yeah.
So it may be the situation where, for example, you don't have RPS 215 to use, but you have got a light touch kind of permit approach. So, I think that's one thing they're looking at is, can they kind of rewrite the permitting kind of regime with respect to these kind of scenarios to make sure that we can achieve kind of swift remediation and make it work better.
Yeah.
But all we're trying to do is clean up and manage spill incidents, which are unpredictable. And until we get on site and start pulling the stuff out of the ground, all that's going to happen is the environment is going to get worse.
Absolutely.
Yeah.
And our whole goal is to
don't make it any worse.
Yeah.
there you go. Golden rule.
Golden
Don't make it
rule.
any worse. John, thank you very much indeed. That's
Thank you.
really excellent. Adrian, thank you very much
No,
for your
pleasure.
wisdom. And Amy, analysis is key.
Yes, it is.
Okay. Now, what I'd like to do is I say, would you like to ask any question? One of the questions that was raised was about whether we could add a module within ISAS to do that. John, have you got any thoughts on that?
In terms of the equipment sort of
Yeah. So
review.
basically, I mean, one of the suggestions was to maybe add a module into the ISAS standard under possibly 2 and 3 for the use of remediation systems in dealing with these pollution incidents.
Yeah, I think so. I think it could be written into that. Obviously, the way the ISAS kind of modules are set at the moment, it looks at the kind of training and competence of staff, in particular, and experience of staff. It doesn't specifically look at equipment as such, but I don't see any reason why it couldn't be extended to that.
Absolutely, yeah.
And that's exactly what where ISAS could assist, I think, really. So, as we said in the presentation there, if ISAS approval of a treatment system is given, then the EA should have some confidence that it's going to perform as the contractors say it's going to perform, and therefore should be a lower risk.
Yeah. Any other comments? Richard, you were suggesting that obviously you want to include this as part of ISAS, and I think it should be. One of the things that we have been doing is we have in the past talked to the EA about using the accredited contract scheme as almost recognition of competence, such that some derogation could be given in these sorts of things. It never got beyond a conversation, and it's something I really do want to pick up using these webinars as examples. It is something I'd be very keen to talk to the EA about. And I don't know if there's any members of the EA who would like to comment, but it would be useful to get their feedback on this. The purpose of doing them is partly to highlight the issues which do arise. And I know there are quite a few contractors on at the moment who would share this particular view and this experience. Any other questions? While you're waiting for the permit, what is happening to the fuel in the ground? Adrian, what do you reckon?
Well, I think the key one, we kind of covered a little bit, didn't we? That's the big risk. And so, particularly gravity is going to be having a big play, and it's going to be continuing to spread out, and depending on groundwater levels and everything else. The quicker it's that golden period that you talked about, the quicker we can keep going with that initial response and reduce it to the extent we can. It's just essential, really. And that's where we need a flexible and responsive kind of regulatory system that allows us some leeway in that response period, as long as it's got a wider environmental benefit. I think that's the key.
Yeah, I would certainly agree with that. Anything you want to add to that, John, or is that fairly accurate?
No, I'd agree. I mean, I think we do get pressured into using alternative techniques that we don't necessarily want to, such as vacuum tankers on turnaround.
Yeah,
something that we're not particularly keen on from a kind of sustainability point of view and a cost point of view as well. Sometimes it's avoidable, but I'm a firm believer, as I said in the webinar, that we need to get control on kind of plumes, and that's what the systems are designed to do, to get 24/7 control and start remediating the ground as quickly as possible.
Yeah, I mean, Sam Mills from Crawford's has just put on, what is the purpose of the permitting scheme? I assume it is to prevent unlawful discharges to ground, but it seems counterproductive to have to wait for such long periods when you could be pumping contamination out of the ground. I think universally we would say completely 100% yes. And what we're trying to do is not make the spill worse. And by delay, we're making the incident worse, which then has more disruption. If it's a household spill, it probably has more disruption to the householders. But one thing's for sure, it's going to cost more to clean it up and take more time, and that is not good at all.
No. And I think it's because it's evolved out of the waste management licensing, really. And so it's designed for permanent installations where you have an extended application period and everything else. So it's designed for a very formal process where you've got a fixed location and you can kind of get lots of information before you submit. We're asking it to not fit that square box, basically.
Yeah, that's great. Good. There don't seem to be any more questions.
I had something.
Please, Amy, go for it.
I can see that swift remediation is key. And then for spill number 3, which was the kerosene one, there was a timescale of 12 weeks for permitting and consent approval. And obviously there were consequences related to this. But John and Adrian and Mark, can you really see things improving significantly? Is there any hope? Are we hopeful?
Yeah, I think so. I'm quietly hopeful. The Environment Agency seem to be making the right noises in terms of reviewing the permitting process. So I do think we will get to a point where there will be a kind of an easier process for permitting. I don't think it's going to go away. I think there's still a place for it to make sure that contractors are doing things properly and that there's no risks to health or the environment in the work that we're doing. But I would like to think that they put something in place that allows us to get onto site quicker and is also going to be cheaper as well. So that would be my hope. Timescale wise, I really don't know. I'd hope something maybe in the next 12 months, but that might be hopeful.
I would hope so. It's something that I think using these webinars to illustrate the issues that we've raised, I do want to put some pressure on the EA to react to it, respond to it. I have to say I'm hopeful, but I am Aries, therefore I'm naturally a very positive person. And if we go by our experience with land contamination risk management, we are still, after 3 years now, trying to make progress. We have made some progress, but the rate of progress is extremely slow, but it is better than it was. So I think we just have to keep pushing. I think we have to use examples like this to illustrate what can be done, what our suggestions are, and how effective those could be. So I think this is a good way of having the dialogue.
But it seems a bit funny, strange as well, because you guys go out on site, you get your work done quickly. The lab then has to turn around the results quickly as well. And then the timescale is 12 weeks. So that's it.
It can't be hard. So the best scenario are those ones where you're allowed to carry on working and carrying on fuel out the ground without a doubt. And in fact, I think the other issue on that second case study with the trade effluent consent, we sort of missed the boat, unfortunately, within that period while we were waiting for the consent to be issued, because now groundwater levels have dropped and we're actually unable to recover as much oil as we were if we'd have been allowed to get onto the site within a couple of weeks.
Yeah, good. Okay then, well, without further ado, I'd like to thank very much Amy, Adrian and John. These 2 webinars have been useful. I think they're a useful discussion of this, and they are really what the bread and butter of most of our UK Spill members are about. We're doing this all the time. So it is something that we enjoy doing and something which is vital. And in all that we're doing, we're trying to protect the environment and, of course, not make it worse. But thank you very much indeed for your time. Thanks for watching. Thanks to our expert panel, and we'll see you next time. Have a good evening. Bye-bye.